Welcome dear students. Here we are going to learn the new topic, new course from MSc first year, that is called as a CHP 210. This is the physical chemistry course. Okay, let me see the syllabus. This is a CHP 210 course, includes the physical chemistry. Okay, this is includes the molecular spectroscopy and nuclear chemistry. The first section will be taught by me, and the second section, that is nuclear chemistry, will be taught by the Jan Rao sir. Okay, so start our topic, that is a molecular spectroscopy. Okay, this molecular spectroscopy has the 2 credit course. The total credit of this course, that is 4. In the first section, that is molecular spectroscopy, has a 2 credit course. This includes the 5 chapters. First, that is a microwave spectroscopy. Second is the IR spectroscopy, that is a infrared spectroscopy. Third, that is the Raman spectroscopy. Fourth chapter we will going to learn, that is electronic spectroscopy, and the last chapter, this is new for you, that is called as a Mossabor spectroscopy. Only the introductory part are included in your syllabus, that is principle, instrumentation, and the application of the Mossabor spectroscopy. Okay, so let's start our syllabus by starting the first chapter, that is called as a microwave spectroscopy. Then what is the microwave spectroscopy? It concerns with a transition between, there is a transition between the rotational energy level in the molecule. There is a change in energy, rotational energy, and according to that there is a transition will happen, that is called as a what? Microwave spectroscopy. The molecule gives a rotational spectrum only if it has a permanent dipole moment. This sentence is very important, and if you know this sentence, if you apply this sentence on the microwave spectroscopy, then you understand all spectroscopy. Okay, let me see what happened here. The rotating molecule, if the molecule is going to rotate, here this A having a negative charge and B having a positive charge. If we rotate this molecule in the clockwise direction, then what happen? This B goes to the upward side and A goes to the downward side. Okay, then what happened? Their polarity is also going to change. Okay, and due to change their polarity, they shows what? Microwave spectroscopy. Okay, and that molecule called as a microwave active molecule. Let me see how any molecule shows the polarity and how we calculate the dipole moment. Here, if we consider the HCl molecule, this hydrogen which has a positive charge, that means +1, and this fluorine has a negative charge, that is a -1. Then what happened here? This atom is very small and this chlorine is what? Bulky molecule, and that's why here this chlorine is more electronegative, and that's why the polarities goes toward the chlorine, and that's why they shows some dipole moment. This is not equal to 0. But if we consider the homonuclear molecule, that is a H2 molecule, this one hydrogen has a +1 charge, another have a -1 charge. Then what happened? This hydrogen have a same size because both are the hydrogen, and that's why what happened here? This +1 charge is neutralized by the -1 charge, which gives the 0. That means their dipole moment is going to 0, and if the dipole moment is 0, then you rotate that molecule, no change will happen on that molecule. But if you consider the HCl molecule, by changing that molecule, their polarity is going to change, and due to change in their polarity, they show some energy, they release some energy. Okay, that is called as a rotational energy. That means this HCl CO gives the rotational spectrum and that's why this molecule shows what? Rotational spectrum. Why? Because this molecule has the dipole moment. Okay, and that's why this is called as what? Microwave active molecule. This is very 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 important in the nature examination. Okay, next is what? H2 Cl2 don't shows any rotational spectrum. Why? Because they doesn't have any dipole moment. That's why by rotating that molecule, no any changes will occur on that molecule. That's why these molecules are what? Microwave inactive molecule. Okay, here then this rotational spectroscopy, which is occurs on what? The gaseous phase molecule. Which molecule? Gaseous phase. Why? Because this rotational motion is going to quantized. What happened? If the molecule is in a gaseous phase, that time this motion is get quantized. That means this motion get converted to the smaller part. Okay, and a number of smaller part. And if in case of the solid and the liquid molecules, the rotational motion is usually what? Quenched due to the collision, okay, between the molecule. If the solid and liquid molecule is there, that molecule shows some collision in that atoms, and that's why here they shows a quenching effect. That means their rotation get mixed up. Okay, here the question is, this question is very important. You have to solve this question. The question is, which of the following molecule shows rotational spectrum and why? You have to answer this question. Okay, and you have to answer this question by sending the message on the WhatsApp group. Okay, next we will learn the next topic, that is the rotational energy of a diatomic molecule. Let me see, this diatomic molecule is what? HCl. How they shows the spectra. Okay, if we consider the HCl, this hydrogen having a +1 and this fluorine has a -1. That means the one pole is positive and another pole is what? Negative. Okay, then if we rotate to the clockwise direction, then the plus on the first clockwise, they goes to here, then after rotating they goes to here, after rotating, and then rotating like this manner, we goes to the original position. Like the same way, what happened? This pole, positive and negative pole, also rotate. Okay, that means in first case the negative charge we can denote it as an arrow. That means this negative charge is here. Then after rotating to the clockwise manner, they changes their direction, and due to changing their direction of the dipole, okay, they showed some fluctuation. This fluctuation, which can be shown by this graph, that is called as a vertical component of dipole versus time. According to the time, they shows fluctuating in the dipole. Okay, and this is spectra is called as a microwave spectrum. Okay, let us see next at the general feature of the rotating system. First, there is rotational motion in the classical mechanics. In that we will learn that is rigid rotor. What is a rigid rotors? That means the molecule in which bonds don't distort under the stress of rotation. That means what? After the rotation of the molecule, here the bond between that is not going to break or distort. That is called as a rigid rotor. Okay, the bond is rigid after rotation. That is called as rigid rotors. Okay, there are two types of the motion. First, that is linear motion. Second, that is what? Angular motion. Linear motion, that means here the straight line motion. That means, for example, here if a girl which is she is move or walk to the straight line on the the road, that is called the linear motion. Okay, and the second, that is what? Angular motion. Angular motion is nothing but what? The circular motion. You can see here, this is a linear motion, that is a straight line motion. Okay, this is a straight line motion. And angular motion, that means what? This is the circular motion. The object or this molecule which move in the clockwise manner or in the circular manner, that is called as the angular motion. And here this linear motion has the velocity which is equal to what? Distance upon time. But in angular motion, they have the angular velocity which can be calculated by the formula, that is radians divided by the times. That means here we consider the radius of the molecule. Okay, From that, you can calculate the linear momentum, which is equal to m into v, and the angular momentum, which is equal to I into omega. Here this m is the mass and v is the velocity, and in case of angular momentum, I is the moment of inertia and omega is the angular velocity. Okay, this moment of inertia which can be calculated by the formula, that is mr square. Okay, and if you find out, if you want to find out the moment of inertia of the molecule, that is equal to summation of the m into r square. Here summation sign is for what? Because any atom in the molecule shows the angular momentum, sorry, a moment of inertia, and that's why here we has to write here the summation sign. Okay, we has to sum of some moment of inertia of each atom which is present in the molecule. Okay, that means the moment of inertia is also called as the mass moment of inertia, which is measure of an object's resistance to changes in its rotation rate. It is the rotational analog of the mass. Let us see here how that molecule shows the moment of inertia. This molecule have the three different moment of inertia, that is called as IA, IB and IC. According to what? According to the axis of rotation. Okay, that means there are the three axes of molecule. This is the x axis, this one is the y axis, and this is the z axis. If this molecule which is rotated to the x axis, that is called as IA. If it is rotated to the y axis, this is called as IB, and z axis, that is called as what? IC. Okay, if we take the example, that is the HCl, then here this is the H and this one is the Cl. Okay, here this is present on the x axis. That's why whenever you rotate this molecule, no change will happen. That's why IA is equal to 0. But whenever you rotate the molecule to the y axis and the z axis, they shows some changes, and their changes are the same. That's why IB is equal to IC. Like this manner, these rigid rotor are classified into the four groups. First, that is a linear rotor. Second is spherical top rotor. Third is called as a symmetric top rotor, and the last one, that is called as asymmetric top rotor. Let me see the first, that is what? Linear rotor. Linear rotor, such as the diatomic or linear molecule is there. That molecule must be what? Heteroatomic molecule. Why? Because only the heteroatomic linear molecule shows microwave activity. Okay, that's why here this molecule are the linear. Like the SCl, we already discussed the example of SCl. The other examples of the linear rotor are OCS, acetylene, CO2. Okay, they have the moment of inertia I is equal to 0 and IB is equal to IC. We already discussed the example of HCl. Next, that is the spherical top rotor. Here the examples are what? The CH4, SiH4, SF4. Okay, that means in that case all the central atom which is bonded to the same atom, that is H4. Here there is all 6 fluorine which is attached to the central sulfur. Okay, and that's why here their moment of inertia is IA is equal to IB is equal to IC. Why? Because let's we see here, you can see in this structure, this is the carbon, and here the blue color are the hydrogens, and here at the x-axis there is one atom is there, another on the y-axis there is a atom is there, and to the z-axis there is a atom is there. That means they have the same distance, and to the same distance there is a atom is there. That's why their moment of inertia are the same. Okay, that's why this type of molecule are called spherical top rotor. That molecule is known as spherical top rotor. Examples are CH4, SiH4 and SF6. Next we will learn that the symmetric top rotor. Examples are what? NH3, CH3Cn, CH3Cl have two equal moment of inertia. The molecule shows what? Two equal moment of inertia, and the third molecule shows a different moment of inertia. They are not equal to IA and IB. Why? You can see here, this is the example of NH3. This is the nitrogen and this is green color ball are the hydrogen. Okay, if we consider this is x-axis, this is y-axis, and here this is what? Z-axis. You can see here at the x-axis there is a atom is there, y-axis another atom is there, but to the z-axis there is a no any atom. That means x IA IB are the same, but IZ to the z-axis IC is different. Okay, that's why this is called as the symmetric top rotor. The symmetric top rotor are classified into two types. First, that is a prolate, and the second one that is called as a oblate. Let me see what is the prolate and oblate. Here whenever this is the spherical top, and whenever the spherical top molecule which is pushing to the inward direction, pushing the pole inward like this, then we get this type of structure. This is called as the oblate symmetric top structure. And if the spherical top which is pushed the pole outward direction like this, push like this, that time this is this gives the what this prolate type of structure. This structure is called as a oblate, and this structure is called as a prolate. This is called as symmetric prolate symmetric top structure molecule. Okay, here the examples, what happened here, we know that in the symmetric top IB is equal to IC but not equal to IA. Okay, that means here IB is equal, B and C are the same but I is different. But here if this IB and IC are greater than IA, then that type of symmetric top molecule is called as a prolate molecule. Example is what? Methyl fluoride. That is what? C here, this is the H and H, and this is what? F. That means what? Here this is the x-axis, this is the y-axis. This x and y-axis both have the hydrogen, but to this z-axis there is a heteroatom is there. That's why this moment of inertia of Z is different. Okay, and here this is less than that of these two. That's why this is IB is equal to IC. These are greater than IA. Okay, that type of symmetric top molecule is known as prolate type of the molecule. The example is what? Methyl fluoride. Second one, if there is a IB is equal to IC which is less than the IA, that is called as a oblate. Example is what? BCl3, boron trichloride. Okay, here in that case what happened? IA is greater than the IB and the IC. This is the two types symmetric top. There are the two types, oblate and prolate. Okay, here examples are NH3, CH3Cl, CH3Cl, CH3 F, or the what? BCl3. Last type, that is called as asymmetric top rotor. The examples are what? H2O, CH3OH, vinyl chloride, CH2 double bond CHCl, and the formaldehyde. Here what is the condition for that? Here this all this moment of inertia of the all atom are the different. That means IA is not equal to B, IB which is not equal to IC. Here you can see in this structure, whenever you rotate this molecule, this IA which is different to IB and IB is different to IC. This type of molecule are called as asymmetric top rotor. And you have to remember the example of all these rotor: linear rotor, spherical rotor, symmetric rotor, and the asymmetric rotor. This is very important. What is the condition for that? First, linear molecule. What is the condition for linear molecule? This linear molecule has the IC is equal to IB but IA is equal to 0. In spherical top molecule, all moment of inertia of XYZ axis have the same, that is IC is equal to IB is equal to IA. In case of symmetric top, here IC is equal to IB which is not equal to IA. If IC is equal to IB which is greater than IA, that is called as what? Here we already discussed, that is called as a prolate, and this is whenever smaller than IA, that is called as a oblate. Okay. Then asymmetric torque, that means IC is greater than IB is greater than IA, or all these are not equal to each other. Okay. The what main thing we have to remember over here, the homonuclear diatomic molecule such as H2O2 and 2Cl2 has zero dipole moment. That's why they have zero change in dipole during the rotation. That means whenever we rotate that molecule, there is no change in the dipole, and that's why no interaction with the radiation. Okay. Hence, these are homonuclear diatomic molecule are what? Microwave inactive. And in case of heteronuclear diatomic molecule, that is HCl, HF and CO, have permanent dipole moment. Okay, they change, the dipole occurs during the rotation, hence the interaction with the radiation takes place, and therefore the heteronuclear diatomic molecule are the microwave active molecule. Okay, here we learn the first chapter, that is what? The rotational spectroscopy, or which is nothing but what? The microwave spectroscopy. We learn the moment of inertia. According to that, here there are the 4 types of the moment of inertia. Okay. Thank you very much for watching this lecture. Okay. Next time, here we will learn the new topic related to the same subject. Okay. Thank you.